Hello everybody, this is Mr. Ainsworth. We're going to get into a drill about graphing inequalities here that are in standard form. By that I mean we have ax plus by is either less than or greater than c. Alright, so let's get right into it here. We got our first inequality here, 4x minus 2y is less than 4, and what we want to do is isolate y first. Let's write that down, isolate y. Alright, and that's why you want to do it is because you want to get it in slope-intercept form so you can see the slope-intercept and you can graph it easily. All right? That's the reason why people are taught this technique. So we have 4x minus 2y is less than 4. All right, 4x is positive here, so I'm going to subtract 4x on both sides. I get negative 2y is less than negative 4x plus 4. Okay, I just added a negative 4x to both sides. Or you can say subtract 4x on both sides. At this point I want to divide by negative 2 everywhere, okay, all terms. When divide by negative 2, got to remember to switch the inequality here to greater than when you divide by a negative. Negative 4 divided by negative 2 is 2, so you get 2x here, and then the minus 2. 4 divided by negative 2 is negative 2. There's my slope, and there's my y-intercept. So the slope is 2 over 1. That means an up 2, right 1. Y-intercept is negative 2, so I got to start here at negative 2. Let's put this in red here. And I'm going to go up 2 from this point, right 1. Up 2, right 1. Up 2, right 1. And go ahead and graph my line. Now I know it's less than here, so this tells me that it's going to be dotted. Okay, so I have a dotted boundary line. You know that from the previous drill. Alright, and it's greater than, so it's going to be above. So I'm going to put above here. All this should make sense, especially if you look at drill number 14 and have that side by side. So I'm going to graph my boundary line here. Alright, there we go. Graph my boundary line. I'm going to grab my eraser and make it dotted. Alright, because it's strictly greater than. And then I'm going to kill my dogs. That's what I'm going to do because they are acting up right now. That's what all that noise is in the background. Okay, sorry for the interruption there. Okay, that's how you handle it. Now there is a secondary way you can do it, so let me just show you that real quick. So let's go on the left hand side and let's write the boundary line. Now the boundary line, all it is the same thing but equal to. So 4x minus 2y is equal to 4. I could have graphed this line using the intercepts. I could have, okay, and the intercepts are easy to work with because all you do is put 0 in here. So when you put 0 in for x, you get negative 2y equals 4, because 4 times x is 0, obviously, and y is negative 2. So there's your y-intercept right here, that's it. So 0, negative 2. And then if I put a 0 in for y, that's gone. I get 4x equals 4. And if 4x equals 4, then obviously x equals 1. And you get 1 comma 0, which is right here. So I could have used intercepts, and then I could have used another point, like the origin right here, the origin here to test to see if it's a solution. And if I put the origin in, I put zeros in both places, right there. And I'm going to test it. Okay, so if I'm going to test the origin, 0 comma 0 to see if it's a solution, I get 0 minus 0 is less than 4. Oops, 0 minus 0. And 0 is obviously less than 4, so you know it's true, and that means it's a solution. And since 0, 0 is a solution, all I have to do is just graph above because the 0, 0 is above the boundary line. So I could have used 3 points right here to do the whole thing. All right, keep that in mind. I could have graphed the intercepts, graphed the boundary line, tested the origin, because dealing with zeros is a piece of cake. I found it was a solution here. The 0, 0 is above the line, so I graph above. Or I could isolate y here and get in slope-intercept form and do it exactly what I did in drill 14. So we could refer to drill 14 and use all those techniques. Okay? So either way, most people are taught this way here, isolate y. It's the most common way, but you could also do it here on the left. Okay, I'll do both, just so you can see both. Okay, so one more time. So let's isolate y here. And you always do that first. So 2x plus 5y is greater than 10. If you're working alone, pause the video, work on it, and then when you're done, press play. Okay? Alright, so let's see what you got here. We're going to 2x is positive, so I'm going to add a negative 2x to both sides. I get 5y is greater than negative 2x plus 10. Divide everything through by 5, and I get y is greater than negative 2/5, which is your slope here, x, plus 2. There's your slope, and there's your y-intercept. So negative 2/5, meaning down 2, right 5. B is 2. There's your y-intercept at 0, 2. Okay, so let's go ahead and graph this. I know that right here, it's dotted and above. So dotted, boundary line, all right, and above. Just by inspection, I know that already, even before I graph. So I plot a point at 2. I go down 2, right 5, and plot a point. It's dotted. I first make my line, though. Okay, first make my line, get my eraser out, and make it dotted. All right, it's above, so I get my highlighter. All right, and shade above. It's that easy. Now, if you want to do intercepts, that's easy too. So you put 0 in, and you put 0 right here. You get 5y is equal to 10. Let's just use the equal to here. And y is 2. Okay, boundary line is when it's equal. And when y is 2, I get 2x equals 10. And when 2x equals 10, well, that's when x is 5, right there. So notice 0, 2 is here. 5, 0 is right here. These are my intercepts. And this is 5, 0, and this right here is 0, 2, excuse me, 0, 2. And then I test my origin to see if it's a solution. So, not 0, 0. I take that back. I want to put the zeros in both places here, and I get 0 plus 0. Is that greater than 10? And the obvious answer is no. 0 is not greater than 10. So that tells me that 0, 0 is not a solution. It's really easy to tell. And if the solution, if 0, 0 is not a solution, it can't be below, so it's got to be above. All right, and so all you have to do is just shade above. So I can do the whole process here by plotting 2 points, drawing the boundary line, testing the origin every single time. All right, and then go from there. I don't have to do all this. If you're not good at it, you can resort to points. How easy is that? Okay. All right, so let's do number 3. Okay, one more time. We got to isolate first. I'm going to write that every single time because I want that to get in your brain, okay? All right, so 2x here minus 3y is less than or equal to 6. And if you're by yourself, pause the video, okay? If you're doing this on your own, pause it, work on it, and then when you're ready, press play. All right, now 2x is positive, so I'm going to subtract 2x on both sides. I get negative 3y is less than or equal to negative 2x plus 6. I want to divide everything through by negative 3, and I got to be careful because I got to switch the inequality here. So I have y is greater than or equal to 2/3 x minus 2 now. There's your slope, there's your y-intercept. So 2/3 means up 2, right 3, and the y-intercept is negative 2 or 0, negative 2. Let's call the y-intercept here. Just by looking at this, I know that it's solid. All right, and above. Solid and above. So what I'm going to do is I'm going to graph the boundary line first. Start at negative 2. I go up 2, right 3. Plot a point. Plot a line. All right, there we go. And I know that it's above, so I just shade above. Now, if you don't want to do that, no big deal. Put a 0 in for x right here. You get negative 3y is less than or equal to 6. Actually make that equal to here because it's a boundary line condition. So equals 6. That means y equals negative 2. That's right here, 0 and negative 2. And if I put a 0 in for y, I get 2x equals 6. And if that's the case, I get x equals 3. There's my x-intercept right here at 0, 3, excuse me, 3, 0. So 0, 3, 0 there. And then I test my origin. I put a 0 here and here. And 0 minus 0, is that less than 6? Well, of course 0 is less than 6. All right? That tells me that 0, 0 is a solution. And because of that, 0, 0 is right here. That's the origin. Because that's the solution, we shade above. Okay? So I could have avoided all this process right here just by plotting 2 points and testing the origin. That's what I've done 3 times in a row, and I've showed you how easy it is. All right? Now you try it on number 4. Pause the video, get started. Alright, so let's give it a shot. We got 3x minus y is greater than or equal to 2. 3x is positive, so I'm going to subtract 3x. I get negative y greater than or equal to negative 3x here, plus 2. I divide by negative 1 on everything, or everything divided by negative 1. And I got to remember to switch the inequality, so I get y is less than or equal to 3x minus 2. There's my slope and there's my y-intercept. Okay, the slope is up 3, right 1. The y-intercept is negative 2, or 0, negative 2. And just by looking at this right here, I know that this right here is solid, and it's less than, and the solutions are below. Okay, so let's go ahead and graph this one. We got negative 2 here. We got to go up 3, right 1, up 3, right 1. You always repeat it a few times. All right, and go ahead and graph your line. We know it's below, so this is below the line here. Okay, below, all right, above. Now, you can use intercepts. So let x equal 0, put a 0 here, and you get negative y equals 2. That means y is negative 2. All right, and there is your y-intercept right here, 0, comma, negative 2. Put 0 in for y. So not here, but here. And you get 3x equals 2, and that means x is equal to 2/3. Okay, so you get 2/3 here, and that's this point right here. 2/3 is obviously between 0 and 1, comma 0, and there's your x-intercept. Then you test at 0, 0. Always test the origin, it's the easiest. So you put a 0 in both locations, and you get 0 minus 0. Is that greater than or equal to 2? And of course that's false. 0 is not greater than or equal to 2. So this is not a solution. Okay, not a solution here. And if the origin right here, here's the origin, you know where it is. If that's not a solution, it can't be on this side, it's got to be on the other side, so you shade away from the origin. Not above, but below. Alright, and that's all there is to it, guys. You should get good in both methods. Alright, and give it a shot. Print a blank copy off, practice again, see how fast you get. It turns out that it's not that hard at all. Alright, I'll see you now, you guys, in the next drill. Work hard at home. Use the pause and play videos, and I'll see you in the next drill.